the Orpheum or something like that. Okay, so is this recording? It is. Okay, so once again, last day we looked at sine law, all right? But today I want to show you another law that will help us out with the other remaining types of angles and triangles. So let's do some investigation, because I actually want to prove the law for you. Okay. So given that you know A and B, so what I'm saying to you is this. You know this side A, and you know this side B, okay? So you know these two things. And you also know the angle between the two known sides, which would be this angle over here, and that would be, of course, angle C. So when you have these three pieces of information, I'm going to ask you, can you find the actual length of side C? So side C, of course, is just this one over here. And right now, I want you to try to do this by splitting up the triangle into two right triangles. So I'm going to ask you to look at this triangle here, please, and I'm going to put this in green. And I also want you to look at this other triangle, which I'm going to put in blue. And I want to see if you can find a relationship between all of these sides. Now, the new side that I created is this line H, which is like the height of the triangle. And so can someone tell me and help me out with looking at the green triangle here? What's the relationship between all three of these sides? What do we use for an equation? If I want to relate H, A, and X. Pythagoras. Good. So can you write down this for me with Pythagoras? X squared plus H squared equals to A squared. That's the relationship that connects all three sides together. Good. Can you do something similar for me now, please, with the triangle in blue? Okay. So in the one in blue, I want you to relate the side C with H and this B minus X, this part here. So hopefully you've got something like this, B minus X all squared plus H squared equals to C squared. Yes? Now, I'd like us to try to combine these two equations together. Notice both equations have a H squared. So I'm going to ask you to solve for H squared for both of these equations. Okay?
What's that?
So what's H? Oh, that's a C, yeah, at the end. I wrote a little squiggly C so you don't get that mixed up with the angle C. So please, once again, solve for H squared. And I want you to do that for both equations now. Okay, and once you solve for H squared for both, what do you think I want you to do next? Since they both equal to H squared, make them equal to each other, right on. So I'm going to put this part and this part together. So therefore we have now A squared minus X squared equals to C squared minus bracket B minus X all squared. Okay. Looking kind of nice. But once again, I'm trying to ask you to solve for C squared. Okay. I don't like this bracket stuff. Shall we kind of expand and simplify? Let's do that. Let's expand and simplify. Okay, so remember B minus X all squared is B minus X times B minus X? Yes, that's right. So go ahead and distribute, right? Okay. So try that on your own. Okay. And then continue to try to simplify. Okay. So get rid of that negatives. I think some things cancel out. And let's see what we get. So A squared minus X squared equals to C squared minus B squared plus 2BX minus X squared. Okay. And I'm going to ask you to see if you can continue to try to simplify this and try to solve this. Okay. Your goal, remember, here is to try to solve for C or C squared. Okay. Right? Our goal is to try to find the length of side C. So I hope you can see that the X squares cancel out. Okay. And if I want you to solve for C, I'm going to say, let's see if we can actually solve for C by leaving C on one side and moving everything else to the other side. So A squared on the left. I'm going to move that negative B squared from the right side to the left side. So that's plus B squared. And then what else do I want to move? This plus 2bx, that's minus 2bx. And there you have it. We've got this equation that's a squared plus b squared minus 2bx equals to c squared. Unfortunately, you don't know what x is. Because I only gave you, if you look at the triangle, I only gave you a, b, and the angle c. So, here's what I'd like you to think about. How can I relate angle C with this x? I heard it. Cosine. So I want you to over here also understand that, hey, cosine of angle C is defined as adjacent over hypotenuse, and the adjacent side is x. What's the hypotenuse? The A value. Good. Why does this help us out? Because I'm going to ask you now to solve for x here. So x equals to A times cosine of angle C. And can you see what I'm trying to do next?
Oh, I get it.
Plug it in. And look what you're going to get. A squared plus b squared minus 2 times b. And instead of x, I'm going to replace that with a cosine of angle C, and this is supposed to equal to c squared. And for those of you who remember cosine law from last year, guess what? This is pretty much it. But I'm just going to rewrite this out a little bit nicer. So we have a squared plus b squared. And instead of minus 2ba, I'm going to put the a in front. So 2ab cosine of angle C, and voila. That equals to c squared. This is cosine law.
So if you want to find C, you go straight away.
So, by the way, if you want to find c, you're right, you have to then take the square root of this big ugly thing. Now, before I comment on anything further, can you see how this looks very much like Pythagoras?
Yes.
Right? You got your c squared, your kind of like longest side. Or it doesn't have to be your longest side now, it's just the side that's opposite this angle C, is equal to a squared plus b squared, but this is the extra bit that you have here. Okay? Now, just to let you know, your textbook actually shows you 3 different forms of cosine law. Okay? And if you want to write down the other forms, this is what they do. Okay, your textbook also has this. B squared plus c squared minus 2bc cosine of angle A equals to a squared. Yeah, it's really just rearranged. They also have this one. They have a squared plus c squared minus 2ac cosine b equals to b squared. Now, I don't want you to memorize all 3 of them. You could if you want to, but I think that's confusing. Okay? I'd rather have you just memorize one and understand what that means. So that's why underneath I tried to show you what cosine law actually means in words. Okay? So let me see if I can try to connect this to the visual picture for you. Here we go. I want you to visualize this. You got a triangle, and it says the following. The square of any side. Okay? So that means that's the c squared part. I'm going to try to color code this. The square of any side. So let's call this side here c. Okay? This side we don't know. The square of any side is equal to what? What does the formula say? Well, it's a squared plus b squared. That's this part here. The sum of the squares of the other 2 sides. That's what this a squared plus b squared means. Meaning, if you want to figure out the length of the third side, you have to know the length of the other 2 sides. So you must know this, and you must know that. Okay? I'm going to try to color code this. Now, what's the next part say? It says minus twice the product of these 2 sides and the cosine of the angle between them. So this part here, I'm going to highlight in blue, is this stuff, which is the extra bit that comes out of the cosine law. Right? Minus, there's the minus sign, twice 2, the product is multiplication of AB, those 2 sides, and the cosine and angle between them. Meaning, you need to know this angle here. Okay? So what I'm saying to you is, knowing 2 sides and the angle between them, you can always calculate the third side using this formula. Okay, I think that's a little bit better than memorizing b squared plus c squared minus 2bc cos a equals a squared and all those other things. Try to understand what you need to get the actual answer. Okay? All right, so keep this in mind now as we turn the page. By the way, before you do that, this is when you actually use cosine law. Okay, when you have the two sides and the contained angle, meaning not SSA, but you have SAS. Notice that the angle is contained in between the two sides. Or when you have all three sides and you want to find one of the angles. Okay, so let's actually try some of these now. If you turn the page. All right, we'll try to apply cosine law to a few questions, and then we'll try some more tricky ones, and then we'll be done for today. Okay? It's so fast, it's not that hard, I hope. Okay, here's example number 1. Diagram represents the radar station at point A, tracking ships B and C. So these are ships B and C, okay? And I want you to calculate the distance between them. So if you want to write down the formula again, you can. I'll write it up here. A squared plus B squared minus 2AB cosine of angle C equals to C squared. Okay, but once again, I don't want you to use the letters A, B, C. I want you to think about, okay, what do I have? What am I trying to find? Okay? Can someone suggest to me what am I trying to find here? I'm trying to find, this side here, which I call CB, or you can call it length A. It's up to you. Okay? I'll call it X so that we don't get confused. So I'm saying X squared is on the right-hand side, and then you have to now help me figure out what numbers go in on the left side over here. What's A and what's B? What could they be? Yeah, it's the 3.8 or the 4.6. Does it matter which one's A, which one's B? No, so it doesn't matter. Okay, so I don't care which one you use, but I'll use A for 3.8 squared plus 4.6 all squared. And then you're just going to minus those two sides put together. And then what else do I need over here? It's minus 2AB cosine of angle C. What's angle C? The 110. And notice that angle is always across from the side that you're actually trying to calculate. Okay? Let's calculate. So bring a calculator, please. Okay. Okay, bring a calculator. I will. All right. So I'm going to actually type this into the calculator now. So 3.8. Okay, I'm going to go bracket 3.8 all squared plus 4.6. Oops, I should put a bracket, I guess. All squared minus 2 times 3.8 times 4.6 times cosine of 110. Make sure you're in degree mode, by the way. Right? Every time. Don't be like Mr. Lee, who messed up on his Math 11 test in grade 11. Okay, I got this as my answer, 47.55. So many of you will write this down, 47.55, and say, oh, that's the length of CB. Don't forget to take the square root. Okay. So what's the square root of 47.55? Now notice on this calculator, you don't have to type in 47.55 again. You can actually just go and use this answer button. So second function minus, and that will show you the answer. What it does is it takes the previous number and sticks it in there for you. And therefore you don't have to memorize all the decimals and blah, 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 blah. So here you go, x equals to 6.9. Kilometers, yes, thank you. Okay? If you have questions with your calculator, please let me know so I can help you out right now. Okay, but I hope you can all practice this and get this. Okay? All right, let's try the next one. Example number 2. So here's another scenario where you have to figure out the missing angle. So in this case, the missing angle, or the one I want to find, is A. And I'm going to ask you to try to figure out the missing angle. Well, if this is the missing angle, remember, in cosine law, okay, the missing angle and that side opposite the angle are connected together. Remember, the angle and once again the side opposite it is connected. So my question to you is, this is the angle. What number here goes on the right-hand side of the cosine law equation? What number should go here? 8. Good, because it's across from the angle that we're looking at. So this should be 8 squared. Okay, the angle and the side across from it is connected. So therefore, then A and B must be the 5 and the 9. And it doesn't matter which one you choose as A or which one you choose as B. just go ahead
We're
and plug them
solving
in.
for cosine C, right?
That's right. So in this case, you're solving for cosine C, or if you want to use the angle theta, it's up to you. Okay, like this. And now let me show you how to actually calculate this, because this one's a little bit more messy and tricky on the calculator. Okay? Before we even do the calculator, let me ask you to think about algebra. Okay? I've got a whole bunch of terms here, plus, plus, and then minus this whole thing that's times together. Okay? I want you to understand that this whole thing sticks together. Okay? 2 times 5 times 9 times cosine C is one big blob. So if I'm asking you to solve for cosine C, or trying to isolate this, what must you do with these other numbers, the 5 squared and the 9 squared? Divide them? Subtract them, right? Like algebra. This is positive 5 squared, we're going to subtract. Positive 9 squared, we're going to subtract. So this is what I'd like you to do. Let's keep the negative 2, the 5, the 9, the cosine theta on the left side. And on the right-hand side, we'll have 8 squared minus 5 squared minus 9 squared. Now notice I haven't actually done the squared calculations yet. If you want to, you can, but I'm going to try to show you how you can put all this into the calculator in one go. Okay. I wanted to solve for cosine theta, not negative 2, 5, 9 cosine theta.
When you multiply them by.
So yeah, let's divide now by all this stuff, right? So let's divide by the negative 2, the 5, and the 9. So once again, you can either multiply it out first, or I'm going to just write it out like this. 8 squared minus 5 squared minus 9 squared divided by negative 2, 5, and 9. Okay? Yes. Now, once again, you're trying to solve for theta, not cosine theta. So what other thing do you need to do now to get rid of that cosine? Inverse, right. So really you're thinking about saying theta is equal to cos inverse of that ugly thing. Okay. Now, if you want to do this all in one go on your calculator, this is what you're going to have to punch in. Okay. Now, let me just tell you, some people don't want to do everything like this because it's too much. Okay. Some people will do this part first, the part in green. They'll evaluate that part first, and then they will actually do the inverse cos.
So let's just see.
Okay. All right, so let's take a look. The one in green. Some people do this, okay? 8 squared, and I'm going to put a bracket here because I'm taking the whole thing in the numerator. So 8 squared minus 5 squared minus 9 squared. Okay, once again, I'm putting brackets because I want this whole thing in the numerator. And I'm going to ask you to divide that by, in bracket, negative 2 times 5 times 9. So this is what you get, 0.466666666 repeating, okay? That's this whole thing here in the bracket. So if you didn't want to write down this ugly thing, you could have just written down 0.4666 dot 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 dot. Okay? Now, your last step, of course, is to do inverse cos. So second function inverse cos, get the answer. There you go, about 62.18 or 62.2 degrees. Okay? Now, ladies and gentlemen, I'll also show you how to do this all in one go. If you wanted to do the calculation in your calculator in one go, like one time, so this is what you do. Inverse cos, and then you've got to be careful with your brackets, okay? An open bracket, 8 squared minus 5 squared minus 9 squared. Close the open bracket, so that's your numerator. Then you got to divide, open bracket again, negative 2 times 5 times 9. Close the bracket, and then you got to close this original one for the inverse cos, and then you can press enter, you'll get the same answer. If you want to do it in one step, you can. If you want to do it in two, that's perfectly fine as well. Okay? Now, ladies and gentlemen, we haven't finished this question yet. This one said, find angle A. There's not two triangles, though. It says, then find the remaining missing angles. So I'm going to ask you now to figure out how you can find the other ones. The other space? Go up here, some up top. I don't know. Let me ask you this. What can you do now to try to find out, let's say, angle C? So you have choice, okay? You can either now, to find angle C, you can use sine law, Or what else could you use? No, you can't use SOHCAHTOA. What else could you use though? What are we learning right now? You could have also used cosine law again
Do it all
because
over again.
you have the three sides. You just have to set it up a little bit different and do this whole thing all over again. Which do you prefer, sine law, cosine law? Okay, so go ahead and try this now then. Okay? There's no such thing as tangent law. Okay, well, that's right. That's why it's no such thing. Okay, try it please, everybody. Try. Okay, now ladies and gentlemen, don't worry too much about your angle, especially the last like tenth of a degree. If you're in the right range, I'll be happy, okay? So angle C is 84.3, and then how about angle B?
Then you just do
Do the what?
the minus.
Do the minusing, yeah. So minus, what's the answer going to be? 34, is it? 34? Around 34 degrees, okay. Like I said, I'm not going to worry too much if you're a little bit off, but if you're a lot off, that could be a big problem.
What if you're like 2 off?
2 degrees off? That's a lot.
Or
But
one
with
degree?
0.2 or 0.3, 1 degree, that's okay, yeah. All right, ladies and gentlemen. I'm going to actually show you the setup for part 3 or example 3. I'm going to actually get you to try this out on your own, okay? 3 is fun.
Whenever
So
you
it's
say
4.
something's fun, it's usually not hard. It's usually hard.
Fun does not equal hard.
That's what all teachers do. They're like, oh, this is going to be so fun. And then
Okay, ladies and gentlemen, what does a parallelogram look like? Try a rectangle that got blown over. Okay, that's what I say. So,
What's a rhombus?
no, a rectangle. A rhombus, by the way, is a square that's been blown over because a rhombus has all 4 sides being the same.
So,
Okay, but a parallelogram only has 2 pairs of
What's
sides.
the one where it's like all different sides, but it's like four sides that are all different?
Quadrilateral, or this one,
Yeah,
trapezoid?
quadrilateral.
Trapezoid? Yeah.
That one's going to be all different?
No.
Okay, quadrilateral.
Okay, let's do this first. All right. Here in this question it says the sides of the parallelogram are 18 and also 10. Now, I hope you understand what a diagonal is. We're just connecting the actual corners together. And can you see how there's a shorter diagonal, which is this one in blue, and a longer diagonal, which is the one in, I'll say red. Okay, so can you see the difference between the two? There's a shorter one and a longer one. They're not the same though.
Why?
So can't you see that the lengths are different? Okay. So my question here says the shorter diagonal has this measure of 14.7. So the line in blue is 14.7. And I'm going to ask you to find the line in red. What's the length of the longer diagonal? Now, how can we go about doing this question? Ultimately, I'm hoping you can see these 2 triangles. Here's a triangle. And notice for this triangle in yellow, I know all 3 sides. So by knowing all 3 sides, what can you find out by using cosine law? One of the angles. Yeah, you can find out all 3 eventually, but you can find out one of them. Which angle do you think we should try to find? This one up here, this one over there, or that one down there? Which one is... Let me try to label this for you. Which angle? This one, A here, the entire thing of B, this small one C, or this one D? Which angle do you think will help us out? B. Why B? I think B is good, but I'll tell you why. Because if you can figure out the entire angle B, you should then be able to figure out the entire angle C. Can you see that? So how is the entire angle C going to help us out to figure out the longest side here, DB? It's opposite of that sign, and we can use cosine. Right on. So if you're thinking about a strategic way to do this, guess what? The first thing you should do is find angle B. Okay? And of course, you're going to use cosine law for that. Okay, leave some space. What's your next step going to be after you found angle B? Find angle C, right. Now, how are angle B and angle C connected to each other? That's right, they add up to 180 degrees. So they are what they call interior angles on the same side of a transversal. They add up to 180 degrees. Okay, so when you have a parallel line like this and 2 parallel lines, and you have a line that cuts through it. This angle plus this angle, x plus y equals to 180. Good. And then how would you find out dB after that? That's right. Use that angle. So find dB by using angle C and cosine law. Okay? So dear friends, this is the setup that I'd like you to try to do. Let's see if you can try this on your own now. Okay? So go ahead and find angle B first, then find angle C, then find dB. On your own. Equation. To find angle B, the side across from that is 14.7. So 14.7 squared equals to, and it doesn't matter which one is A and which one is B, so I'll go 10 and 18 minus 2 times 10 times 18 times cosine of angle B. Okay? Cosine of angle B equals to 14.7. Okay, and of course you're going to have to solve for cosine B, and that's just 14.7 squared minus 10 squared minus 18 squared, all divided by negative 2 times 10 times 18. I'll do this on my calculator now. Oops. This is a pretty involved question, isn't it? Negative 2 times 10 times 18.
Well, I just rounded it.
I got 54.72.
Yeah.
Okay. So B is 54.7 degrees, I'll say. Okay. So now with that, let's see if you can keep going on. Okay, so try to find angle C, then try to find dB. And if you're done example 3, try example number 4 on your own. If you thought 3 was fun, 4 is funner.
Great.
Okay. Wait for me. But for dB here, the length of dB, I will say the following. I've got my A, which is 10. Got my B, which is 18, minus 2 times 10 times 18 times cosine of that angle 125.3. And that equals to dB all squared. So I'm going to actually type all this into my calculator now, and let's see what I get. 10 squared plus 18 squared minus 2 times 10 times 18 times cos 125.3. 632 point blah 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 blah. And I'm done, right? No. Yeah, don't forget your last step. Always take the square root. So if you take the square root of that, I predict the answer is about 25.14. Okay? Don't forget your units as well, please, dear friends. Centimeters. Done.
Oh, I got one more.
Close enough. Okay. All right. Let's take a look at the next one. All right, and then we'll do a few more, and not yet. That's why you don't wait for me. You try it on your own first.
I don't get it.
Then you ask your friends.
But I just don't get it. That.
Okay. The next one. I love this question. Because I know that many of you in my classroom don't look at me, but you look at my clock.
No, I should look at that. We do.
Right?
Look at that one, yeah.
You look at that clock. Do you know that some people don't know how to read clocks that are like that anymore? The analog ones? I had a grade 5 students like, you know what the time is? I'm like, here. They're like, I can't read that. Where are the numbers? I'm like, what? Because they're all using digital clocks, right? 9, like that, whatever that one is. Huh? Okay. Now, let's take a look. So, I've got this question here. Now, here's what I'm going to ask you to do. Let's draw a picture first, and then I'm going to give you some hints as to how you can solve this by looking at the degrees per hour and all that kind of stuff. But let's draw a picture first. Draw a clock for me, please. Whee!
Yeah, we can't do that.
Do the best you can. Okay? Now, notice with the clock, here's 12, Here's 3. Here's 6. Here's 9. Right? And then, of course, because it's 10:25, Jack, this is for you.
Horrible.
The minute hand points to what number? What number does the minute hand point to? The 5, right? For 25. Okay. Now, where does the hour hand point to? If you said 10 like this, I say, really? Does the hour hand always stay at the 10 throughout the whole hour of 10 o'clock? It moves too. So it's actually going to be not close to 10 like that, but where should it be closer to?
In between 10 and
Okay, now it's almost halfway, but that would be 10:30, right? So I don't really want halfway. I want it to be just a little bit less than halfway. So a little bit less. Okay? I don't know how much less, but that's the case.
Too little.
That's too much? Okay, fine.
That's too little.
Okay. I will change it for you. Okay. Now, the question I have for you is this. Determine the straight line distance between the tips of the hand. So ultimately, I'm asking you to calculate this distance in black here. Right? What is that distance in black? Now, can you see what type of triangle you created here? It's a triangle. Now, do you know two sides of this triangle? Yeah? Do you, or can you find the third side then? Not yet. What are we missing? The angle. The angle, yes. The angle here is what you need to figure out. So the first step you need to do here is find the angle. And I'm going to let you think about that right now first. Okay, before I give you the answer, I'm going to ask you to think about how many degrees are in a full circle, if I go a full circle around. 360, good. So notice there are 360 degrees in a circle. So let me ask you then, okay, if I were to travel, and how many minutes are there in an hour again? 60. So the minute hand, okay, let's talk about the minute hand now. How many degrees does the minute hand travel in 1 minute? That's right, 360 degrees divided by 60 minutes. Guess what? It travels 6 degrees per minute. So that's what I'm saying about the rate, okay? Now, before you even finish this off, you are also going to need to know this. What about the hour hand, okay? My question to you is then, well, for every minute in an hour, how many degrees does the hour hand travel? And the hour hand is a smaller one. Okay, so this one's a little more trickier. Let me ask you this if you're not too sure. Going from 10 to 11, if I were to look at the hour hand, in that 1 hour, how many degrees does it travel? Oh, I'm talking about that whole hour. Huh? How many degrees for the whole thing from 10 to 11? This little wedge here, how many degrees? 30 degrees. Good. How do you get 30? 360 divided by 12. Awesome. So this whole wedge here, if I were to look at it, is 30 degrees. Okay, so in 1 hour, it goes 30 degrees. So for the hour hand, it'd be 30 degrees, and we're going to divide that by 60, because there's 60 minutes. So for the hour hand, it's correct, 0.5 degrees per minute. Okay, now using those two pieces of information, I'm saying now you can figure out the angle in purple here. Okay, I'll let you try that first, and once you figure that out, the next step is pretty straightforward. To find the straight length, it's just use cosine law. But the question is, what is the angle in purple equal to? Think about it. So let me help you out with the angle, and to do this, I'm actually going to blow this up so you can see it a little bit better. Okay. Okay, now, I'm asking you to figure out that angle in purple. Now, let me just try to erase this, okay? Oops, I erased too much now. That's not good. I want to erase that black line. Please. Okay, now, oops.
Oh my goodness.
All right, let me ask you this. I will suggest to you to do the following, okay? Let me ask you to go from the 5 here to just this part 10, okay? So let's do that part of the angle first. So going from the number 5 all the way to number 10, how many wedges do you have here? Well, 5 to 6 is one wedge, right? 6 to 7, 7 to 8, 8 to 9, 9 to 10. That's 5 of them, okay? 5 of these wedges. Each wedge is how many degrees? 30. So that's 5 times 30, which is 150. Okay? Now, we've got this little extra bit here as well. This extra bit in green here is hard to see, but let me ask you that. For 10 to 10:25, guess what? That's 25 minutes. And each one of those little minutes, how many degrees does the little hour hand travel? Only 0.5 of a degree. So what's 25 times 0.5? That's 12.5 degrees. Put them all together to give you the actual angle in purple. What would it be? 150 plus 12.5, which gives us 162.5 degrees. That's the angle between these two hands. All right. So now the rest is pretty straightforward. Let's use cosine law. And what are my numbers here? Is it 8.7? Yeah, 8.7 squared plus 15.6 squared minus 2 times 8.7 times 15.6 times cosine of 162.5. And that will equal to your longest side, I'll say c squared. Okay? Did someone calculate this for me? What's the answer here? What's c equal to? You're trying it right now? Okay, try right now. I'll do it with you, I guess. 8.7 squared. Oops. Okay, plus 15.6 squared minus 2 times 8.7 times 15.6 times cos 162.5, 577.92. Okay. 577.92. Last step. Take the square root. How about 24.04? Yes? Yeah? Centimeters. Good. Okay. Ladies and gentlemen. I made it too big. Is that better? Another way of doing this. Okay. How do we actually calculate the area triangle formula again? Area equals to base, base times height divided by 2. Good. Now, I want you to be aware of one particular thing, though. Okay, note, the base and the height must be, it must be perpendicular. Because if it's not, this doesn't work. Now, in this particular example, I can treat the base as the length BC, or the number 4. But what's the height going to be in this picture? You have to make one, sure. And I'll make one here. Okay, that's your height. So the question I have for you now is, how do I actually calculate the height? Using trig. SOHCAHTOA stuff again, yeah. Which ratio should I use? Sine, cosine, or tangent? Sine, you bet. Sine 50 equals to h over 5. So what's h equal to? How about 5 times sine of 50? Now, don't actually do the calculations yet, because now what I'd like you to see is if you want to use that area formula, you now can. Because the height now is that, you know the base is 4, life is good.
So that's easy?
So base is 4 times the height, which is 5 times sine 50 divided by 2. And you're done.
Really? That's it?
Yeah, that's it.
How come you made it look so complicated?
So go ahead and actually type this in. 4 times 5 times sine 50 divided by 2. Voila, you're done. 7.66. Okay? Now, you're thinking, why are we doing this, Mr. Lee? Because I actually want to show you a formula for this. Okay? And it's going to be related to this actual example we just did. So underneath, I said, well, how could we, in general, find the area of a non-right triangle? Given that you know these two things. Given that you know the two sides and the contained angle. So in a picture, I'm saying this. Okay, draw this picture for me, please. Here's A, B, C. You know the side length of AB. You know the side length of BC. And you know the angle between them. Okay, you know, as in K-N-O-W. No, not no, N-O. So you know those. When you know those things, what can we actually do? Well, let's just do the same thing like above. What did I do? I dropped the perpendicular. Okay? Solve for h. How do I solve for h here, by the way? What's the relationship again? Sine of the angle B is equal to h over, I guess it'll be this side I know. Let's call this side here C, I guess. Okay. And then if we were to continue on, I get h equals to c times sine b. Right? That's your height. But once again, what's my area formula here? It's base times height divided by 2. What's the base in this particular example that I'm doing? What do we call the base? The length BC, good. Or in this case, I'm going to use the letter A to represent that. So can you see the following? The base is A. The height is C sine B all over 2. So guess what in this case? The area formula is just this, 1/2, okay, of A times C times the sine of angle B. So if you ever want to figure out the area of a triangle now, this formula works for all triangles, okay? All you need to know is two sides, and B is the angle between the two sides. Okay? The ultimate area law. Yeah. Let's stop here for today, okay? I'm not going to do example 6 and 7. We'll do that next time. You can try to start your homework, okay? And it's on the bottom of the last page. Next day when you come, I guess I'll finish 6 and 7. I'll give you the rest of the period to actually work on your own stuff, math related. I'll give you the practice exam, and hopefully you'll be ready for your real one on Thursday.
I think I'll be sick on Thursday.